Yes, friends. In this video, I am going to tell you about principle of superposition of Colombian forces. Actually, force between 2 point charges, is attractive or repulsive, and that is calculated by applying Coulomb's law. So, the force of attraction repulsion between any 2 point charges may be called as Colombian force. Generally, this term is used in higher classes as well as in our topics coming forward. Suppose it is any charge q1 here placed at any point P here, and it is surrounded by many point charges like q2, q3, q4, and so on. By putting, suppose we have charge q1 and q2 only, the force acting on q1 due to q2, if they are like, will be along this direction, and I have written it here as F12, means force acting on charge q1 due to q2. Similarly, if I put here q3 charge, the force of repulsion, if q3 negative, then it will be attractive. Again, we will be calculated by using Coulomb's law, and q4 charge apply force in this direction. So, what is the total force on any charge when there is a system of many point charges? Will be the vector sum of all these forces, and this is called principle of superposition of Coulombian force. By putting q3 or q4 near q1 does not affect the force of q2 and q1, and similarly force between q and q3 is not affected by presence of q4 and q2. They will be acting as such. You have learned in class 11 also, Newton law of gravitation. A body is attracted by other body around it, and the force vector quantity, so it should be added vectorially. So I am writing here, according to this principle, force on any charge, say q1, due to, according to the force on any charge, say q1, due to other point charges is equal to the vector sum of all the forces acting on it due to all the charges placed around it. The force on any charge, force between any 2 point charge, I should say, force between any 2-point charges is not affected due to the presence of other charges. You know, force is vector quantity. So force is acting on a body simply will be the vector sum of all forces, not only Coulomb force. Manually we apply force on a body, so and we may apply so many forces. So the resultant force will be vector sum. So in this figure, in given figure, force on charge Q1, force on charge Q1 due to charges Q2, Q3, Q4 and so on is given by vector F is equal to F12 plus F13 plus F14 and so on up to plus Fn resultant force, and where F12, F23, F13 will be calculated using Coulomb's law, where F12 equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R12 square into unit vector R12 and so on. Every force we determine using Coulomb's law, and their vector sum will tell you the total force acting on this. Now I come here to solve some problem for you and to tell many things about Coulomb force and its application. There is one term I have explained somewhere else also, equilibrium. When a body or system of bodies is said to be in equilibrium, please note this, because questions comes and people are not aware of the definition of equilibrium. You know, in class 11 you have learned the effect of force on any body, the effect of torque on a body. The force produces linear acceleration. The force applied on a body may produce linear acceleration, while torque produces angular acceleration. But that force should be, or torque should be, unbalanced. So when body or system body is said to be in equilibrium, if resultant of all the forces, little bit problem in writing here, resultant, the word is resultant of all the forces and torques. So torque means moment of force. moment of force. If resultant of all forces and all torques, moment of force acting on a body, acting on a body is zero, then body is said to be in equilibrium. Please be very sure what you are learning. Equilibrium. When resultant of all force, all torque acting on body is zero, then body is said to be in equilibrium. People generally get confused. That body in motion cannot be in equilibrium. This common brain. That body in motion is not. Resultant of force should be zero. If according to Newton's second law, if a body is moving with constant velocity, then acceleration zero and F is equal to ma. If A vector is zero, so F is zero. So condition for equilibrium is that resultant of force is acting on body should be zero, whether it is rest or in motion. When body is in equilibrium while in motion, that equilibrium in fact is called kinetic equilibrium or dynamic or kinetic equilibrium. Kinetic equilibrium. Dynamic or kinetic equilibrium means when body is in motion but net force acting on it zero, means acceleration zero, or also in rotatory motion. In your room, the fan rotating with constant speed is in dynamic equilibrium. Why it is so? The torque applied by the machine inside the fan is equal to retarding force produced by air on it. So net force becomes zero. Now if body at rest and no net force acting on it, that is called static equilibrium. Static equilibrium. These terms teachers do not teach in the class, and students feel a lot of problem when confusion surrounds them. Now these are static and dynamic equilibrium. So dynamic static equilibrium resultant of body at rest and resultant of all force, all torque acting on it zero. Dynamic means when body in motion but net force zero. Acceleration, any type of acceleration is zero. Now further, static equilibrium. Static equilibrium further can be equilibrium. Static. The body is static means at rest. So two types of there. Stable equilibrium and number two, unstable equilibrium. Unstable equilibrium. In class 12, there are many topics where the questions are asked about equilibrium, and people feel a lot of difficulty. Students are learner, and learner always remain under tension. Please remove that tension. Learn easily. Don't be in hurry. Don't be under pressure. stable equilibrium. If body is gently if body is slightly, I should say slightly moved away from equilibrium position. And then left free. Then the force, if the forces or torques produced bring the body back to original position, then equilibrium is stable. You can see here, suppose it is a cone placed here, and it will be in stable equilibrium here about this condition. If we move it little away from this condition, suppose it is gently made like this, so this position can change. On releasing, it will return back to original position. Then it will be in stable equilibrium. The force torque will be produced in this to bring it back. And if this torque and force is produced do not bring it back, it is unstable equilibrium. You can write it yourself or you can see the book, but please be sure about stable and unstable equilibrium. If torque and force is produced on slightly making the body away from equilibrium position, produced in such a way that body return back to original position, then it is stable equilibrium. I can demonstrate here this remote here placed on my hand. If I take this way, it will come back. It is, but if I place it like this and anyhow it is displaced, it will not come back. So that is unstable equilibrium. In coming video, I will be telling you problems based on Coulomb